Hello everyone. Welcome to the solution of LeetCode problem 1498, named number of subsequences that satisfy the given sum condition. In this problem, we are given an array of integers and an integer target, and we have to return the number of non-empty subsequences in the given array such that the sum of minimum and maximum element on it is less than or equal to the target. Since the answer may be very large, we have to return the answer modulo 10 to the power 9 plus 7, which is a prime number. Suppose in the first example, the array contains 4 elements, which is 3, 5, 6, and 7, and the target is 9. So now there are 4 subsequences that satisfy the given condition. Here, for this subsequence, only element 3, the minimum value plus maximum value will be 3 plus 3, which is 6, which is less than is equal to 9. For this subsequence, 3 and 5, the minimum and the maximum value summation will be 3 plus 5, which is 8, which is less than is equal to 9. The subsequence contains 3, 5, and 6. Here, the minimum value is 3 and the maximum value is 6. So their summation is 9, which is less than is equal to 9. And finally, for this subsequence 3 and 6, the minimum and the maximum summation will be less than is equal to 9. So we can say that in the given input, there are 4 possible subsequences where the sum of minimum value and the maximum value is less than or is equal to the target. I hope you understood the problem statement. Now the constraint are, the array length can be in between 1 to 10 to the power 5, and each of the array element can be in between 1 to 10 to the power 6, and the value of the target can be in between 1 to 10 to the power 6 as well. I hope you understood the constraint. Now let's move on to the algorithm. Now, to solve this problem, we have taken the first example where the array contains 4 elements, which is 3, 5, 6, and 7. Now, we are going to solve this problem by using 2 pointers mechanism. At first, we will indicate one pointer I, which will indicate or pointing to the first element, and we will point another pointer j, which is point to the last element. Now, here for this test case, the target value is 9. So now, at first, we have to check whether the summation of the pointer I and the summation of the pointer value j is less than is equal to t or not. So here we can see that the I is indicating the element 3 and j is indicating the element 7. So their summation will be 10. But unfortunately, 10 is not less than is equal to 9. So here we have to shift our j pointer. Now our j pointer is pointing to this previous element 6. Now we have to another check the condition whether the summation is less than is equal to target or not. Here the summation of pointer I, 3 plus 6 will be 9. Wait, fortunately, the summation of the pointer value I and j less than is equal to 9. So we can say that this is one possible subsequence where the minimum value and the maximum value and their summation is less than is equal to the target. Now we have to check for this specific subsequence how many other subsequence in this subsequence it has, such that in those subsequence has the summation of minimum value and the maximum value less than is equal to target. So here, suppose if we extract the subsequence, current subsequence will be 3, 5, and 6. Now, if we consider this subsequence, suppose we have fixed the first value, because let's say we have fixed this value 3 here, because if we did not fix the smallest value. That means the chance of the summation is violating or getting bigger than the target will be maximum. So here we have fixed the value 3 right now. Now let us try to understand how many other value we have. We have 2 other value, right? So the possible subsequence is that one is 3, another is 3, 5, another is 3, 6, another is 3, 5, 6. So we can say that there are 4 possible subsequence if we fixed the value 3. Now, as we have seen that this subsequence has the length of 3, and if I fixed one element 3, then the remaining length will be 2. So the number of subsequence is 2 to the power 2, where this 2 comes from the length of the remaining subsequence, which is this. Now, the algorithm is pretty simple. We have to apply 2-pointer approach, and if any of 2 pointers, their summation is less than is equal to the target, then we have to append the 2 to the power n value to the answer, where n is the remaining element of the specific subsequence. Suppose, what is n? Suppose our subsequence has 3 start positions. Now it has lots of remaining element. So here n is the number of element that is presented here. I hope you understood the intuition behind the problem. And now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named num subsequence, which has a parameter a as a vector and integer k, which is a target. Now, we are using sorting function to apply the 2 pointers mechanism. Now here, the modulus value is 1 into 10 to the power 9 plus 7. And we are storing the size of the vector a into the variable name int. Now, here we are using one vector which will calculate the 2 to the power n. Here, for each of the I in the vector, we will store the value 2 to the power I here. Now, after that, we are using one variable named answer, and we are using left and right pointer. Initially, left pointer is pointing to the first element and the right pointer is pointing to the last element. Now, we are using conditions where left pointer is also repetitively less than is equal to the right pointer. And if in any iteration, the summation of the left pointer and the right pointer is greater than k, that means we have to reduce the right pointer. That means in this case, if we reduce the right pointer, we have to look after the smaller element. Otherwise, if the summation of left pointer and the right pointer is less than is equal to k, that means we have found one subsequence here. Now, we have to add the 2 to the power of right minus left value to the answer and perform the modulus operation. After that, we have to increase the left pointer. And finally, we have to return the answer modulus of mod. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this problem, the time complexity is big O of n log n because we are using sorting function on n number of elements. That's why the time complexity is big O of n log n. And the space complexity is big O of n because we are using one extra array to store the exponential value. That's why the space complexity is big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.